Hey guys, we're back. We're going to graph this last function. We'll call it a night or a day or a morning or wherever you are at on this thing. First off, just thought I'd show you, some more pictures just for fun. Levi's totally getting into puzzles right now, and my wife has got him this cool train puzzle because he's obsessed with trains too. So that's him after he completed it, or maybe I completed it mainly, but he helped me a lot on that puzzle. He's also into dinosaurs, and on his birthday, as you can see, he's getting this dinosaur collection. He likes to line them up and have them like in rows and stuff. This is his new one. It's kind of a freaky one. Look at that mouth. It actually opens and shuts. So it's got some crazy looking eyes. So, and a new dinosaur book that, yes, he's already ripped a bunch of the pages because he doesn't know how to flip pages yet, but he's getting better. He's getting better. So anyway, back to the good stuff now. Let's graph 2 cosecant of 4x minus 2 pi. Before we can graph this, something you must know. A cosecant is the reciprocal of sine. I know you think it would be cosine because of that c right there, right? Everyone looks at that. Oh, it must be cosine. Nope, it's not. It's reciprocal of sine. So you know that cosecant, SC is equal to 1 over sine of x. And we're going to use that later on. What we really need to do is we need to graph sine of this right here. So let's do that. Let's graph the sine function. There we go. So we're going to graph, instead of this function, we're going to graph its sine function. It's reciprocal. So we're going to graph f of x is equal to 2 sine of 4x minus 2 pi. Okay. But I need to factor out this 4 before I can figure out its phase shift. So I'm going to redo this function. We're going to look for f of x is equal to 2 sine. I factored out the 4. That's going to determine your period, that 4x. And when you factor out a 4 out of this, you get minus pi over 2. Now, if you don't believe me, check this out. 4 times pi over 2. What's 4 divided by 2? Well, that's 2 pi. So you can think about that a little more. Pause this, think about that. But this is the function we're going to graph. We'll graph that right on here. And then we'll graph the reciprocal function just like we did on this last one, the purple ones. It's going to be just like that. Okay. So first off, amplitude. The amplitude on this is 2. So we're going to give it an amplitude of 2. A vertical shift. What's the vertical shift? Well, nothing's being added to the outside of this, therefore there's a 0 vertical shift. Okay. Now, because of this, we know our max and min. Our max is equal to 2 right there, plus our 0, which is 2. Our min is equal to negative 2 right there, plus our 0, our vertical shift, which is negative 2. Okay, so we know that our function is going to go from 2 to negative 2. Do I change the color? I wonder if there's a cool, easy way to change color. Probably isn't. Probably isn't. Let's just go from here. 1, 2. 1, 2. So we know it's going to be between negative 2 and 2 right there. Okay. Top and bottom right there. Okay, so now let's find the period. The period after factoring out this 4 is identified as pi over 2. So there's your period for this function right here. Oh, sorry, phase shift. I'm sorry, that's a phase shift. So that's pi over 2. Pi over 2. And the period is this 4 right here. Or the b determines it. Because we're dealing with sine, it's 2 pi divided by the 4. So the period is 2 pi divided by 4, which is equal to pi over 2. Thus, it's going to make one complete cycle in pi over 2. There's a lot of stuff happening. These are going to be very skinny graphs, guys. This 4 made these graphs very, very skinny, okay? So I'm not going to graph all of them that could possibly fit in here. Let's stretch this thing out just a little bit to make things a little more interesting, a little easier to graph here. Let's make this, we'll break it up into 8s. How about this is going to be right here, pi over 8. This is going to be, if that's pi over 8, we'll make this pi over 4. This is 1 pi over 8 to 3 pi over 8. And then this right here is pi over 2. Okay, so that's one complete cycle. We would have to go this way too. 1, 2, 3, 4, negative pi over 8, negative pi over 4, 3 pi over 4, but negative 3 pi over 8, excuse me, and then pi over 2, negative. Okay. Now they're not going to look skinny because I kind of stretched this out, right? This usually would be 2 pi right here, or maybe a pi, but I stretched it out so we can kind of see what's going on in this really small skinny area. And we could go out even further with this. Let's do one more here. If that's pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. This is 6 pi over 8, which is 3 pi over 4. This is 7 pi over 8. And this is 2 pi. Okay. So we got this filled in right here. What are we doing again? That was a lot to fill in. Oh yes, we're graphing this function right here. Okay. Let's first start with graphing the function. We'll get the amplitude in there. We'll get a full cycle within this first pi over 2. We'll graph that function in gray. And then what we'll do is we'll apply this phase shift to it right here, this pi over 2 phase shift to it. Once we apply that phase shift to it, then what we can do is we'll graph our cosecant function based off of this 2 sine of 4 quantity x minus pi over 2 function. Okay, easier said than done, right? But I think you're going to be surprised about something. So just so you know, check this out. So sine, we know because it is a positive in front of here, it's going to start right here. Sine always starts at the origin, as long as you haven't phase shifted yet, which this situation hasn't. And then it goes up, unless this is negative there. It goes up at this direction, goes to the top, comes back down, goes to the bottom, and then ends right there at the middle. Notice that this duration right here was pi over 2, which was our period. It made one complete cycle. Right? See this one complete cycle? In pi over 2. Okay? And now we're going to repeat that cycle again. Now it goes back up to the top, back down to the middle, down to the bottom, and right there. And it does another cycle in another pi over 2. Okay? And we're going to do one more over here. It goes down to the bottom, back to the middle, up to the top, and down to the middle. It completes another cycle in that section right there. Okay? That's another cycle right there. Okay. Now, what they want you to do now, so let's just make sure we're all on the same page. We just did this, okay? We have not incorporated this phase shift right here into it yet. Let's incorporate it right now. What that phase shift does is it takes this function right here in yellow, and it shifts it to the right pi over 2, okay? So it shifts it to the right this whole distance right here, this whole distance. What do you notice? So you shift a point that's right here to a point that's right there. If it makes this much of a shift, what do you notice? Let's see what happens. Check this out. This point right here, it can be shifted over pi over 2. That would shift it all the way to that point. Well, there's already a point there. This point right here would shift it all the way over to this. Oh, there's already a point there. This point would be shifted all the way. Oh, there's already a point there. Okay, weird. This point would be shifted all. Oh, there's already a point there. Interesting. This point would be shifted. Oh, there's already a point there. Notice that it shifted every point to where there is a point at the end of the cycle. Really what it's doing is this phase shift is moving it over, but it's moving it right on top of where it once was. Does that make sense? Even though it's shifted over. So all these points will land back on this function where it once was before. So that goes to that point. This goes to this point right here. This goes to that point right there. This goes to that point right there. That goes to that point right there. Isn't that weird? So really, we just have the same function going on here. This pi over 2. Is that always going to happen, guys? No. Guys, that does not always happen. But after the phase shift, okay? you will be right back where we started. You shifted back to where you were. Okay, that's what this phase shift right here did. So I guess it didn't change anything. Now that we have all these things taken care of, we can graph our cosecant function. It works just like before. We need to graph the vertical asymptotes at every zero, because we know that when we divide by zero, okay, when we divide, see, we're dividing by sine right here. Remember, this is our sine function. If you ever divide by zero, so whenever the sine function right here is zero, you're going to create a vertical asymptote. That happens right here, right here, right here, right here, right here, right here, right here. Okay, so let's put in our vertical asymptotes. Here's one, here's another vertical asymptote, here's another vertical asymptote, here's another vertical asymptote. Notice I have yet to graph this function, right? I haven't graphed it yet. I'm just graphing this reciprocal function and getting ready to graph that function, okay? So let's graph it. This is the function I'm going to graph. I'm going to do it in purple. Well, I'll do it in, how about I do it in red, okay? I start off at this point right here on top, and I just bowl up right there, okay? I come back to the bottom, this bottom point, and I bowl down. Come back to this top point, bowl up. Go to this bottom point right here, bowl down. Go to this top point, bowl up. Go to this bottom point, bowl down. Remember, this happens forever. It goes, you know, this direction forever and this direction forever, but it would take forever to do it. So your final function is this purple right here. Here's your final function. This function is 2 cosecant of 4x minus 2 pi. Right there. Okay, so hopefully this video helped you with graphing. This is hard. This is very hard stuff. Okay, I know you guys are struggling through this stuff, but you got to give it a shot. Put forth your fullest effort on this. Try as much as you can. I thought making this video, even though it took me an hour and 10 minutes to make this video for you guys, in between all the egg eating I did, I think this is more beneficial than just giving you a solutions guide because of how difficult these problems are. So I hope this was helpful, and you guys have a great Tuesday, and I will see you all on Wednesday. Oh, here, let's do one more picture of Levi. No, what is this a picture of? What did he get there? I don't know. Let's see. There's got to be some more cute pictures here. Oh, this is Levi at daycare. Oh, and his this is his birthday cake. Yeah, we're teachers. We can't really afford much, so that's what he got. But he loved it, and he's got 3 candles right there for his birthday. Anyway, have a great day, guys.